Welcome to today's Explainer. We're diving headfirst into the absolute biggest technological shift of our generation, generative AI. And to figure out exactly what's happening under the hood, we're going to follow a graphic designer named Emma. Her daily workflow is going to completely ground this super technical process in reality, showing us how a tiny spark of an idea in a human brain gets mathematically translated into this incredibly complex machine-generated masterpiece. Let's get right into it.
So Emma's whole workflow flipped upside down the day she tried a new tool. Not a tool that just finds or sorts old files, but one that actually synthesizes entirely new visuals. It brings up this really profound question, right? Like, how exactly does a machine make the jump from just fetching data to actually creating something totally original? We're not just asking computers to do a quick search anymore. We are literally asking them to build things from scratch. Understanding that leap is absolutely crucial.
Section 1. Meet generative AI. Okay, so the real breakthrough clicks when you compare the two types of AI. Traditional AI is super analytical. Its main gig is categorizing, sorting, and predicting based on stuff that already exists. It's kind of like a hyper-organized, incredibly fast librarian. But generative AI, that is synthetic. It takes all those learned patterns and uses them to output entirely original text, images, and audio. It's basically mimicking human creativity. So instead of just finding you the right book on the shelf, it's literally writing a brand new one based on the underlying structure of every single book it's ever processed.
Section 2. Beyond just text.
And wow, the implications here scale way beyond just chatting with a bot. In content creation, these models are spinning up full narratives, complex code, and structured essays from just a few words. Over in art and design, text is transforming into unique visual assets, which completely streamlines the daily grind for designers like Emma. Music? The AI is synthesizing complex audio tracks and replicating human voices with, honestly, stunning accuracy. And then there's healthcare. This is a huge one. It's actually simulating disease progression and generating synthetic data so doctors can speed up medical research without ever risking patient privacy. It's a massive, massive infrastructural shift.
Section 3. How does it work?
Let's say Emma types in a prompt. That immediately kicks off a fascinating three-step pipeline to take raw text and synthesize a visual. Let's look under the hood at how this architecture actually operates and how these systems systematically turn human language into millions of highly detailed pixels. First up, data collection and learning. Long before Emma even touches her keyboard, the model has digested absolutely massive data sets of image and text pairs. Now here's the kicker. It doesn't just memorize photos. It actually learns the underlying statistical relationships. It figures out what makes a cat, or exactly how light bounces off a pair of sunglasses. By mapping all these features out in this multidimensional space, the model builds a really deep, foundational understanding of our visual world. The more data it sees, the richer and more accurate that foundation gets. Step 2 brings in the transformer architecture. When Emma hits enter, the transformer doesn't just read her prompt left to right like we would. Instead, it uses this brilliant attention mechanism to weigh how important every single word is compared to all the other words. It links concepts, like our cat and our sunglasses, to those visual patterns it learned during training. It's essentially deciding exactly how these totally distinct elements need to interact visually. This right here is where the model really starts to grasp the true contextual intent of the prompt.
Now, all that contextual magic relies on something called tokens. The AI literally chops the text up into smaller mathematical pieces, or tokens. This is absolutely essential because it lets the model process spatial relationships. It suddenly understands that those sunglasses need to be specifically resting on the cat's face, not just, floating weirdly in the background. Tokens are basically the ultimate bridge between our human vocabulary and the machine's complex math.
Section 4. Learning and improving. But hey, these models aren't perfect right out of the gate. Sometimes the AI misinterprets those tokens and actually does generate an image with sunglasses floating awkwardly next to the cat. When that happens, human feedback is a real game changer. Emma can just flag that output as incorrect. The model then takes that specific feedback and actually internalizes it to fix its future generations. It's this continuous, highly dynamic loop that guarantees the system is constantly evolving, not just stagnated.
This whole optimization process is driven by something called reinforcement learning. It's pretty straightforward. The AI is mathematically rewarded when it gets things right and penalized when it messes up. By constantly cycling through this trial, error, and reward process, the model updates its internal weights. It's basically fine-tuning its own behavior so it gets remarkably more accurate over time, all based on actual human preferences and corrections.
And the sheer scale of this architecture, it's kind of mind-blowing. We are talking about models governed by billions, sometimes even trillions of parameters. Carefully curated by data scientists, these parameters act as the weights and connections inside the neural network. They dictate exactly how the model processes information. Think of them as the mathematical synapses of the system. Generally speaking, throwing more parameters into the mix gives you a much more nuanced, versatile, and highly capable AI. So cut back to Emma. She sits down later and prompts the AI for a complex, futuristic cityscape.
The result she gets is completely unique. As we can see, the AI isn't just copy and pasting pieces of past data. No, it's synthesizing all those learned patterns to execute a genuinely synthetic form of creativity. It's truly generating something original. It's taking those abstract math concepts and successfully rendering them into something that has literally never existed before.
All right, we've covered a lot of ground today. We've seen exactly how generative AI analyzes data, maps context using transformers and tokens, and constantly refines billions of parameters through reinforcement learning. Now that we've totally demystified how this incredible architecture turns simple text into brilliant, net-new creations, the only question left for you is, what are you going to create next?